This video is the first from chapter 11, which talks about oblique triangles. Now, previously up to this point, we've dealt with right triangles, and right triangles, again, contained an angle that was 90 degrees, or a right angle. Oblique triangles, or general triangles, are triangles that do not contain a 90-degree angle. So, in other words, we have no right angle in this case. And the two methods that we are going to learn to solve these types of triangles are known as the law of sines and the law of cosines. So we are going to start off with section 11.1, which is the law of sines. Now, anytime you're solving a triangle, and we said this before, you have to have three pieces of information. Previously, one of those pieces of information was that we had a 90-degree angle, so we only needed two other pieces of information. Now we need three pieces of information, and one of those always has to be a side. So solving a triangle entails finding all of the unknown sides and angles. Of a triangle. So again, I said for this we always need three pieces of information, one of which needs to be a side. And again, this goes back to the fact that we have similar triangles that would produce the same ratio. If we don't determine one of those sides, then we won't know how big or small this triangle is to begin with. Again, just to recap, opposite angle C is opposite side C, angle A is opposite side A, and angle B is opposite side B, same as before. Now, if we are given two sides and an angle opposite to one of them, this is very important to have the opposite pairing, we can use law of sines. Same thing if we're given two angles and a side opposite to one of them, we can use the law of sines. So anytime we've got these opposite pairings, then we can use the law of sines. If we don't have that, for instance, if we have two sides and an included angle, for instance, C and B, and we have the included angle A, we have to use the law of cosines. Also, if we're given all three sides, we need to use the law of cosines. And we'll talk about that in 11.3. For now, let's look at the law of sines. The law of sines is a simple ratio. Side A is compared to the sine of angle A, side B is compared to the sine of angle B, and side C is compared to the sine of angle C. And all three of these ratios are equal. Now, we can also rewrite this with the reciprocals. We can say the sine of A over A is equal to the sine of angle B over side B. It's also equal to the sine of angle C over side C. And be very careful here to distinguish between your uppercase and lowercase c, which one is the angle and which one is the side. Again, just a real quick refresher of significant digits, the way the book discusses it. If your angle is expressed in degrees, the length of the side is 2 significant digits. If you've got 1/10 of a degree or a minute, 3 significant digits on the length, and 1/100th of a degree or a second is 4 significant digits on the length. So let's look at using the law of sines. And again, the first thing we always want to do is draw our triangle. Now, this doesn't have to be to scale, doesn't have to be exact, just has to give us something to look at so we can figure out our pairings. So I'm going to put A down here, was given as 69 degrees. Side A is opposite to it, is 25 meters. And side B, I'll put over here, is 16.5 meters. Since side B was here, I'm putting angle B down here. Our remaining angle C and side C are filled in opposite to each other as well. Again, I'm telling you to express answers to 2 significant digits. So in this case, we are going to need to find the other pieces. The first thing we always want to do is, based on the given information, we've got an opposite pairing, so that will complete one of our ratios. We want to find the missing piece to the other ratio. So in this case, we've got side B, but we need angle B. So I'm going to put that on the top of my fraction and divide by my 16.5. And then I'm going to set this equal to the given information, which is the sine of 69 degrees divided by 25. Again, we're just using those ratios listed above. I'm using the second set so that I keep what I'm looking for in the numerator. And again, that's just to save some time with arithmetic later. Because in this case, now all we have to do is multiply by 16.5 to get rid of it there. And we end up with the sine of angle B is equal to 16.5 times the sine of 69 degrees, and I'm going to put this in parentheses because it's very important that we do in the calculator, and then divided by 25. So if we get our calculator here, we take 16.5 times the sine of 69, and again we need to make sure we close that parentheses, otherwise it's going to take the sine of everything afterwards. We need to make sure it's only taking the sine of 69, and then we're going to divide by 25. So you should have ended up with 0.61616. And again, anytime we're trying to find an angle, in this case we are going to do sine inverse of 6.61616, and this is going to give us our angle B. And again, with the calculator, we can hit second sign for sine inverse and then second answer, and it'll just use that previous number, and we end up with about 38 degrees. So I'm going to come over here and fill that in a different color so that we know that we have it. And now we're going to need to move on. At this point, the easiest thing to do is to find the other angle. So now we are going to find angle C, which is just a matter, again, every triangle adds up to 180 degrees. So we have 180 minus 69 minus our 38. So 180 minus 69 minus the 38 that we just found, we end up with 73 degrees. So I will write that in up top here. And then we go back to the law of sines to find side C. So in this case, I'm going to write the fraction a little bit differently because I want side C to be in the numerator because that's what I'm looking for. And this is going to be divided by the sine of that angle we just found, which was 73 degrees. But the important thing here is we want to go back to the given information if possible. So I'm going to compare this to 25 divided by the sine of 69 because that was the information that was given. Nothing was calculated, so we reduced the amount of error that we introduce into this problem. In this case, we need to multiply both sides by sine of 73 degrees to get it out of the denominator. So C is going to be 25 times the sine of 73 degrees. Again, make sure you're careful with those parentheses. Divided by the sine of 69 degrees. So if we move this over here so we can see, we have 25 times the sine of 73, close that parentheses, divided by the sine of 69, close that parentheses, and we end up with 25.6 approximately, and our units were meters. In this case, I also want to come over here and just write down all of our answers. So A was given as 25, B was given as 16.5, and I know I said 2 significant digits, but since both those lengths were given in 3 significant digits, I'm going to list the third one in 3 significant digits as well. So we found C to be 25.6 meters. And if we come over here, all of our angles, angle A was given as 69 degrees, we found angle B as 38 degrees, and we found angle C as 73 degrees. And again, we check to see that the smallest side, in this case B, is corresponding to the smallest angle, and the largest side, 25.6, is corresponding to the largest angle. And again, this is just a way to check to make sure that we have a pretty good idea that everything was set up correctly. If this is not working out correctly, you need to go back and see where things went wrong. So I want you to try this example since it's very similar to the last one we did. Pause the video now and then resume to find the correct answer. So in this case, the pieces that were missing were side A, and angle B. Using the law of sine similar to the last one, you should have found angle B first to be 50.1 degrees, and then subtracting from 180, you should have gotten A to be 72.4 degrees. And then again, using law of sines to find side A, you should have found that side A was approximately 187.6 miles. And again, it's always good to come over here and put everything listed here so that we can see and make sure that we've completed everything. And then again, we can easily see that the smallest angle, 50.1, is opposite the smallest side, 151, and the largest side, 187.6, is opposite the largest angle, 72.4. Try a few more examples here. This next example, we're given two angles and a side. It's going to be a similar process, except we can technically find the third angle first because we have the other two. So I'm going to put C down here as 59.6 degrees, angle B over here as 43.9 degrees, and then side B up here is 4760 kilometers. So that puts side C over here, angle A up here, and side A on the bottom. Again, opposite pairings always going with each other. So in this case, like I said, we can find angle A first. That's relatively easy. It's just going to be 180 minus 59.6 minus 43.9. And we come up with 76.5 degrees. So we can fill that in up here. We can also make our list down here. Angle A is 76.5 degrees. Angle B is 43.9 degrees, and angle C is 59.6 degrees. We were also given that side B is 4760 kilometers, and we need to find side A and side C. So we found that angle. Now we can go through and find our other sides using the law of sines. So it doesn't really matter which one we find first. I'll find A next since that was the angle that we just dealt with. If we want to find side A over the sine of angle A we just found to be 76.5, this is going to equal our given information, which is 4760 divided by the sine of 43.9. Again, we always go with the opposite pairings here. So we'll multiply that over. We get A is going to be 4760 times the sine of 76.5 degrees, again in parentheses, divided by the sine of 43.9 degrees. So if we go to our calculator, we end up with 4760 times the sine of 76.5, close that parentheses, divided by the sine of 43.9, close that parentheses, and we hit enter. We end up with 6675. So A is approximately 6675. Again, I'm going to kind of disregard these significant digits. I'm going to give it in 4 significant digits because that was the original information. And this is kilometers, so we can fill this in over here. And finally, we need to find side C. So side C over the sine of the angle given, which was 59.6 degrees, is going to equal the same ratio, 4760 divided by the sine of 43.9 degrees. So C in this case is going to be 4760 times the sine of 59.6 degrees, and this is divided by 43.9 degrees. So kind of a little trick, if you will. Since this was already put in our calculator, we can hit second entry, and we can just kind of scroll over here to this angle that we're replacing. This is still 4760, sine of 59.6 this time. Still have the closed parentheses, still have the sine of 43.9 in the denominator. Or you can re-enter the entire thing. And we end up with 5921 approximately. And again, this is in kilometers. So we'll write this in over on the other side, just to make sure that we kept track of everything. And again, to see that side B is the smallest angle opposite the smallest side, and side A is the largest angle opposite the largest side. For these last two examples, I want you to pause the video and work through them, and then resume the video to see if you have the correct answers. Again, remember that with these, we're dealing with degree, minutes, and seconds. So again, in our calculator, we need to go to second angle to get our degree and minute, and to get the seconds, it's again the alpha button and then the plus sign. So pause the video now and work through these two examples. So for example 4, you had to find angle C first because we didn't have any opposite pairings to start off with. But since we were given angles A and B, it was relatively easy to find angle C by just subtracting from 180. And again, remember with your calculator, you would take 180 minus 85, and then you'd hit that second angle, you'd get the degree symbol. 45, you'd hit second angle, and then you'd get the minute symbol, and then you would have your 15, and you'd hit alpha, and then this button here. Then you would subtract again the 31, you go to angle, get your degree, 14, angle to get your minute, and 35 to get your second, and you would end up with 63.00. Again, if you go to second angle and hit number 4 for DMS, degree, minute, seconds, it would give you 63 degrees, 0 minutes, 10 seconds. Then we can just work through the law of sines as we've done before, and we should get that side B was 5.120 feet, and side A was 2.663 feet. Again, smallest side is A, opposite smallest angle. Largest angle is B, opposite largest side B. For example 5, very similar again. In this case though, we needed to go to the law of sines first. Again, we set this up. We only had one option. We had to find angle B first, and you should have found that to be 29 degrees, 33 minutes, and 2 seconds. Subtracting from 180, you should get C is 100 degrees, 55 minutes, and 8 seconds. And then going back to the law of sines, you should have found that side C was about 48,478 feet. Again, in this case, smallest angle is B, opposite smallest side B, and angle C is the largest by far, and it is the largest side by far as well. So this concludes the video for 11.1. Please go online now and complete your homework for this section.